Hello everyone, it's me Tabo and welcome to another episode of Coding for Superheroes. Like I said the last time, today's lesson we're going to be creating a mini game. Now this is going to be a very simple project which is going to be built on the principles that we learned in the last two tutorials. So I'm just going to give you a quick demo so that you can see and then can carry on. Alright, so that is what our project is looking like and that's what we're going to be building today. I just want to kind of make a few notes before we start. The point of this tutorial is to give you an idea of how you can apply the things that you have learned. I chose something very simple. In this tutorial, you're going to be using a static rigid body, an active rigid body, and we're going to have one constraint, which will be the box that will be dangling underneath the plane. The point of this is to show you how simplicity can help you to actually understand these principles better, creating a project that is based on simple things, but yet you have a full application that you can share with people because it is clear that you can use these things to actually create live projects that people can interact with. So I hope this illustrates the point to keep things simple as a learner so that you don't have to deal with too many complexities which might discourage you in the end. So just take that into consideration. And if you have not yet subscribed, now is the time to subscribe, hit the like button and press that notification bell so that you can always be notified about upcoming tutorials. So without saying a lot, let's just jump right into the project and start coding. Okay, so if you are watching this video for the first time and you have not watched the previous tutorials, then I suggest that you watch the previous tutorials because everything that I'm going to be doing here is based on those tutorials. I'm gonna include a link in the description so you can go there and watch those tutorials and then come back to this one. All right, over here, I've got a boilerplate. So what I'm gonna start doing is, first of all, pasting in all of the global variables that we're going to be using for this project. But just to give you like a quick run through, as you remember from the last tutorials, this is how we run our Ammojs project. You've got our Ammojs promise here, and then once Ammo is ready for us, then we'll call start. Start is this function over here, and this is where we're going to be running pretty much the application. We'll be putting in functions here that are going to be part of the entire application. So we've got set physics. This is where we set our physics. Over here, this is set graphics. This is where we do our Threejs setup. Now you are familiar with this by now. Then after that, then we create a render function. This is where we're going to be rendering everything that you're going to be seeing on the screen. And over here, we have an update physics. And in here, we're going to be updating the physics. So I'm going to start pasting in all the relevant global variables and then I'll explain as I go along. All right, so what you can do is then make sure that you also have all of these. So as I paste, just pay attention to all of that and make sure that you type in all of these variables because these are important for the rest of our project. Make sure that you include that as well. And then I'm going to include these as well. Now I'm going to start also explaining what this is because this is important. I'm just going to explain right now. These are HTML tags that I'm going to be using because there's a lot of CSS that's also going to be included in this, but I will not be explaining so much the CSS part. I will just paste in and then you can just copy it as it is. All right, in the style part, I'm going to be including this, all of this CSS. This is what's going to be running most of our interactions. So as you've seen, the icons that pop up every time you miss or hit the spot, or let's just say when you drop the box inside of the other box, then there are prompts that show you whether you have succeeded or you have failed. So these are some of the icons that are included, and we're going to be accessing them. So just make sure that you include all of the CSS, because this is integral to our entire project. Now, don't you worry if this is taking time. Every time whatever we create, I will always come back to the relevant code or highlight which part of the code is connected to that functionality. Okay, but for now, just copy these and make sure that you have everything. So these are the animations that we're also going to be using for the interaction. And then inside the body, I'm also going to paste some HTML tags that also go along with the CSS. So in here, we're going to be using some audio for some of the interactions. So we're going to use an audio tag. So make sure that you have all of these. I will include the entire project, and I will also include the relevant resources for the project. And I will explain some of the things about these. For instance, I have these audios that I'm using. Now I got these from Pixabay. These have a Creative Commons copyright, so I'm just including them for lessons purposes, but you can go to Pixabay and have a look at the copyright and what it allows you to do or not do with these resources. But they are not for you to sell or do anything of that sort, but you can use them as you like and you can modify them as you like. And make sure that you include that as well. So all of this HTML, make sure that you have it. So you can pause and just type all of this. Okay, just so you understand, it ends here. Everything that I've pasted ends here, starts here, and ends here. Okay, I just want to come back to this one over here. I think I pasted this, but we don't actually need this, so I'm going to remove it. And inside of our start function, I'm going to paste this variable over here. I'm just going to assign it a value, and I'm going to make it into a new MOBT transform. I'm just doing this because we're going to be using this later, so I just want to make sure that I don't forget to do it, because the way that I'm going to be moving through this lesson, there's a chance that I might not remember. So I don't want to do that and get errors. So just to prevent that, make sure that this TMP trans, it's one of the global variables. Just make sure that you assign it a value inside of the start function. Okay, so what we're going to do is go to set graphics. Inside here, this is where we have our Threejs setup. So we've got a clock, we've got renderer as usual, and the usual setup. We're going to be using shadow maps, so I'm using PCF soft shadow map, and I'll also be using an ambient light in the scene. Here I'm going to set the camera in the position Y equal to 1, then in position Z equal to 50. I create a variable here called camera direction, and this is going to be where our camera will be looking at. So I'm not going to be using an orbit control for the scene, so everything is going to be fixed. The camera is going to be fixed in this position. All right, so we're going to start by creating a variable called manager. Now this is just what's going to be helping us manage our GLTF loader. So this is what our setup is going to look like. Create a manager called from the new 3 loading manager, and then manage.onload, we are going to call a function called start screen, and then here we create our GLTF loader, and then we pass it the manager loading manager that we just created over here. And then over here we will say manager.onProgress equals to URL items loaded items total. We will be using a loading bar, so this is meant to just manage the loading bar so that it shows us how far along we are in the loading process. So when you open the application, this is the first thing that you're going to see. You're going to see a loader bar, but in this case, it happens so quickly that it doesn't really make much of a difference. You see it, but it's quick. But for a bigger project, this is necessary, because if you have a lot of assets that are going to be taking time before they load, then you want that to be what your user is seeing. while everything is getting ready in the background. So this is what that is doing. And so it is calling the progress bar. Progress bar is an HTML that we created over here. This is the HTML that we were loading earlier. So over here, we've got a progress bar. So this is the part that's going to be managing that. Or, well, this is the part that is being managed by the. And then next, we will load our assets. Our assets are named game.env.test_1. I will also include this in the description link. So in here, I'm just going to be traversing through the objects and making some changes to them. In this case, I'm just checking if it's a mesh. And if the name of it is not ground, then I'm going to set cast shadow to true. And I'm going to set receive shadow also to true. And if it is ground, then I'm only going to set the receive shadow to true. Then after that, I will add assets to the scene. I will create function start screen. So in here, when this is called, then we are going to close the loading screen, and then we're going to put up the start screen. Now you saw the splash screen when I introduced the lesson, the one that had the press start button. That's what's going to be popping up. So once the loader is finished, then the splash screen is what's going to be showing. So here we're going to turn it off, then turn on the splash screen. That's going to say the game is ready, so you can press start if you want to start playing. So all we're going to be doing is just setting display to none for loading text and for the progress bar. And we're also now here we're going to set the display to block for our screen image, and we're going to set the start button's display to initial. So this is going to make them visible. In CSS, when you set your display to none, it removes the element. So it is not rendered, but it is also not in there. If you just make it, if you just turn off the visibility, it is still there. It will still take up space on the screen. So this is the reason why I'm using display, because when you have display, then it will completely remove it. So once we're done with that, then we're going to take our start button. We're going to add an event listener to it, a click event listener. And when you click it, it's going to then call a function called imported assets. So next up, we're going to create this function called imported assets. All right, so inside of imported assets, we have a variable called game state. It is this variable over here. So inside here, we've got a property called gamePlayOn, which is equal to false. So what we're going to be doing here is the first thing that we're going to do is set GameState.playOn to true. You will see what that means in the next parts of the lesson. It is making sure that the certain parts of the code do not run up until gameplay is set to true. Otherwise, the game would be playing in the background behind the splash screen. So by the time you press play, things would have already been happening in the background. So that's what this is doing. It's preventing anything or the game from actually starting before the button is pressed. And then here, similar to what we did in start screen, we're also going to shut down the image display, and we're going to also turn off the style display, the button style display. So both will be none. And here we're going to set our score. Score is also another HTML tag, which is just going to be keeping track of our score. So now that the game has started, we want to see also the scoreboard. So this is just basically making it visible. And then here we will set the alpha of our background color to 0. So everything that is, let me just say, all the HTML tags that I'm switching on and off are all inside of this main window. Here it is over here. Now you see everything is in this main window, and this main window has a background color. So what I'm doing here, I'm just turning the alpha down so that we can still see the HTML tags that are inside. We can still see its children, instead of turning the visibility off, which will then turn everything off, meaning all the children will also not be visible. I'm just instead turning off the alpha, so every other element will still be visible on the screen. And then in here, I'm gonna start naming some of the assets that are loaded into our scene. So what happens is that the manager here calls start screen. So we do everything that we need to do in start screen, and start screen calls this. import asset. But by the time this is called, it means that our assets are ready. It's just that in this case, we wanted to manage the UI first before we start dealing with our assets. So now in imported assets, we're going to start naming or assigning variables to some of the objects in our scene. Now, these are the objects that are going to be the active parts of our scene. So here we've got box 1. This is going to be the base of our box. Now, if you're wondering what box is the box in which we will be dropping all of the other boxes. Okay, the main box that will be the container that we're supposed to drop the boxes into. I know, too many boxes. And here we're going to assign the variable direction light, dir light. This is just basically assigning it to the direction light, which is already in our scene. Now, all of these assets, I should also mention, are created in the Threejs editor. So I just basically built the entire scene in there and then exported the GLTF file. So now I'm importing everything and then just assigning variables to all the relevant objects in the scene. So here we've got a direction light. So since we have shadows in our scene, I'm just setting up the shadows. So I'm going to say direction light cache equals to true. Then the target will be just the origin. I just wanted to point to the center of our scene, or to look at the center of our scene. And then the intensity will be 1. Okay, I see here that I'm casting shadow twice. If this happens, excuse me. So here we're going to set the shadow bias to minus 0.001. And then the map size will be 1024. That's the width and the height. And then this is our near settings. It will be 0.1. Far settings will be 500. And then our left will be set to 50. Right will be set to minus 50. Top will be 50, bottom will be minus 50, and our shadow radius will be equal to 3. This is just to smooth out our shadow so that it's not so sharp or it doesn't have any jagged edges or to kind of manage anti-aliasing. But that can also be managed with adjusting the size of your map. But in this case, it's fine because everything is kind of like in the background, so you don't really see so much of the details in that regard. And then here we're also gonna capture our ambient light. In this case, I am setting the ambient light to 0 because I already have an ambient light that I've got set up. Yeah, I didn't remove it because, I keep making changes to the scene. So I just want to keep things as they are. Sorry. So in this case, we're gonna just turn the intensity of the ambient light to 0. Okay, just so that we don't have like a washed out scene from too many lights. And then here we're gonna get the plane, which is the airplane. So this is inside of a group. So all the different parts of the plane are in a group. So we're gonna get that entire group. And then this is the box group. That is the main container that we're dropping all the boxes into. So we're gonna assign it this variable, and then we're gonna add it inside this static bodies array. Now this is part of the global variables that we created. So we're just going to put it inside that array. And here we're going to create a 3.box. Okay, we have a global variable once again called dropbox3. Now this is going to be the box 3 that we're going to use for the small box, the one that we're going to be dropping inside the container. Because in this case, we're going to use it to track the intersection between the small box and the main container. That is to check whether the box is inside of the container. That's how we're going to be doing it. I'm using this method, and instead of using collision detection from Ammojs, which in this particular case was going to be a little too complicated. So this is kind of the path of least resistance. This is the easiest way that I thought I could use to avoid unnecessary complications, because the amount of checks I would have to do with Ammojs is just ridiculous. So it just didn't make any sense. So we're going to be using the box 3 model to manage a lot of the intersections or collisions. So then we're going to set the box 3 according to our object. So what this does is just basically uses the size of our object. It will just be a perfect fit for that. Inside of the drop box, we're going to create a property called obj3, and then we're going to assign it our box group. So inside of the box 3, because we want to also check whether this box 3 belongs to a particular Threejs object. So we just cross check into. So in this here, we're assigning the propeller variable. That's the propeller propeller for the plane. The entire plane group has different parts in it. So this is the propeller, which we're going to be animating also. So that's why I am creating a separate variable for that, so that I can animate the rotation of the propeller. And then here we're gonna also assign ground to our ground object. So this is gonna be the ground floor, and we're also gonna create a box 3 for it, ground box 3. So we also gonna use this to check when the box lands on the ground. So we're gonna make a comparison. If it lands on the ground, it means that it's a fail. If it lands inside the box or inside the container, then it is a successful drop. That's how we determine that. So similar to what we did over here, we're going to create the shape from our ground object, and then we're going to push it inside an array. After that, we're going to call a function called boxes, and boxes takes an argument of an array. So it's going to iterate this array and then create shapes and rigid bodies for the different objects. Next, then we will create the boxes function. So boxes, like I said, takes an argument of an array. So here we've got our array. We will create a variable or another array called side boxes. Then we will create a variable called base box. Then over here, we're going to create a variable called mass, and this is going to be equal to 0. Here we create a variable called box3, and this will be equal to a new 3.box3. We create a variable called object scale. We create an obj quad object. This will be holding the quaternion values that we're going to be using also to create our shape and rigid body. We create a variable called obj pos, transform, ms, local inertia, rb info, and body. So in here, we're going to iterate. We're going to go through our array. So what this is going to be doing, it's just going to check the names, and if this is true, then we're going to compute a bounding box, and then we're going to push it into this side box array, this that we created over here. And then in here, we're going to check for base. So any object that has the name base in it, then we're going to assign it to this variable over here. Simple as that. So now we're going to go through the side boxes array, and we're going to then create shapes and rigid bodies for these items that are in this array. So then we set the box3 according to this object over here, and then we get its size by saying box3.getSize. So this will be the scale that we're going to be using to assign to our shape. Obj pos will be equal to the world position of this item. We assign transform to a new Ammojs.bt transform. We set its identity. We set the origin according to obj pos over here. We got the world position, so now we're assigning it to our transform. And then here we're going to set the rotation by using the quaternion values that we created in this object over here. Well, this process you are familiar with, so this is how we just create shapes and the rigid body afterwards. Then ms will be equal to new Ammojs default motion state, and then we're gonna pass it the transform. And then here we're gonna create the shape. We're gonna use a box shape, and then we're gonna give it these values from our obj scale. This is the scale that we got by using the box3.getScale. And then we're gonna set the margin to 0.1. Local inertia will be equal to Ammojs.bt vector 3. We'll set it to 0, 0, 0. And then the collision shapes calculate local inertia. We'll give it this mass, which is equal to 0, and then pass it local inertia. RB info, we pass mass, motion state, collision shape, and local inertia. Then the body will be equal to a rigid body, and we're going to pass it the info. Then we're going to say item.user data.tag equals to item.name. Body.3object equals to item. This is also, I think it's actually not really necessary, because this is useful when you're using, but some parts of this code might not be clean, because these are parts that I probably missed out on when I was removing some of the code that is not really useful, but it doesn't do any harm anyway. It's fine, just follow along. Physics world.add rigid body, then we just add our body inside. So we're still inside the boxes function. So once we're done creating the boxes, so now we're gonna create a shape for our base. So here we create a shape for the base. That is just the base of the box, because the box is also made up of, or the container is made up of different parts. So we're pretty much doing the same thing here. So you can just copy that. And so now, like all the other shapes, then we're just gonna add the body to our physics world. And then next we create a shape for the ground. We're gonna go through the same process, and once we're done, we're gonna add it to our physics world. So next we will create our constraint object. So here we're gonna say plane pause. Plane pause is just a variable, a global variable that we created. What this is doing, it's gonna take the plane. The plane group is our plane. Here we're copying the position of our plane, and we're going to be using this position later to manage moving the plane back and forth from the start point and the end point. That's what that is doing. So here we create a variable called radius. We're going to set the radius to 1, and then scale, it's all 1 1 1. Quaternion also 0 0, and then for world it's going to be 1. The mass here is equal to 2. We create a transform equal to new bc.ammo transform, create a variable called block, and we create 2 variables here. So we're going to be using this one to reference. We're going to be using it and calling it in a different function. So we set our block's cast shadow to true, and then here we also create a box 3 for it. We create it from block, and then we will set the position of block to the plane's position. The reason why we're doing this is when we're dragging the constraint, if you don't do that, then it will start spinning out of control. So it's better when they move together, they start at the same point and then they move together. Otherwise, it will just create these really wild rotations for the constraint object. So we don't want that. So here we're gonna assign it the plane's position initially, and then we're gonna give it a scale. Then we're gonna set block's cast shadow to true, and we're gonna also set receive shadow to true. Then we add it to our scene. Then over here we just do the same thing. We just create a transform. We give it the necessary values. That's the plane's position. We give it the scale, and then we create a motion state, pass a transform, create a shape using box shape. Okay, we create local inertia, and then after that we pass the collision shapes, calculate local inertia. We give it mass and local inertia. Then we create the rigid body info. We pass it to the rigid body. Here we disable deactivation. We set the damping to 0.1, 0.1. The damping is the swinging. It's to reduce the swinging a bit so that it doesn't swing so wildly. And then we add it to our physics world. Then we just create a property called physics body, and we assign it our physics body. We create a variable called name. Oh well, we're not creating it. It already has a variable, a property called name. So we're going to assign the name property equal to package, and then we're going to do the same thing here for our rigid body. We're going to create a property called 3object, and then we're going to assign it to block. Then we add it to our rigid bodies array. This is where we're going to create our constraint. We create a variable called block pivot, and this is equal to Ammojs bt vector 3. We give it 0 on the x, 1 on the y, and 0 on the z. Then here we've got a variable called p2p. This is just means point to point. It's a global variable that we're now going to assign it to our bt point to point constraint. We pass it the block body, which is the rigid body, and then we pass it our pivot. Then we say physics world dot add constraint. We add it to our physics world. We set that to false. Then here I'm gonna set block dot user data dot constraint equal to p2p, and then I'm going to return block. So I am going to be using this function to create new constraint blocks every time. Okay, just above our create constraint function, I am going to create a mouse click function. All right, so inside the mouse click, this is where I'm going to be controlling drop in the box. So every time I click the mouse, then it will drop the box. So it drops the box by removing the constraint on it. So as soon as the constraint is off, then the physics will naturally just take over and it will fall. So here I'm checking to see if gamestat.gameplay on is equal to true, and I'm checking if block.name is not equal to delivered. Now what that means is once I have dropped a box, if I did not put this here, then it will try to then remove the constraint again, right? So it will now be trying to remove the constraint twice, which will then give me an error. So this is also to manage that. So, but when all of this passes, then we remove the constraint and then we destroy the constraint as well from Ammojs to free up memory. So this is what mouse click is going to be doing. All right, so next I'm going to go into our render function and I'm going to paste some code here. So all of this is inside an if statement. Now the if statement is also to check if game state play on equals to true. So if this is not true, then nothing is going to be rendered in here. So none of this is going to be working. But once that is true, first I will check. In this case, I am checking the position of our plane. What this does is once the plane has passed a certain mark, then I want it to move quickly or to move fast, because when the plane flies and then you drop, then you have to wait for it to get to the end, and at the constant speed that it's traveling, it takes long. That's what I've noticed. So this is just to speed it up, but for simplicity's sake, for now, let's just switch it off, okay, so that I can then illustrate to you later why that is. Okay, so just for now, I'm just gonna turn it off. If you can hear my keyboard, excuse me, because my laptop actually just bombed out on me, so now I'm using like an old keyboard just so that I can actually finish this lesson. Then I have to then repair my laptop or find out what is actually wrong. All right, so here then we're gonna check the number of box packages. Now what number of box packages is the overall amount of boxes that we're gonna need to drop. Now this is just, at the moment I've set it to 3 so that I can make a quick illustration. But let's say the assignment is that, okay, you have 10 boxes, and out of 10 boxes you're supposed to drop 6 inside the container in order for it to be a success, right? If it's less than 50%, then it's a lose, then you have failed the mission. That's kind of what it is. So the number of boxes is just that. So we have a fixed number of boxes. This is from the global variable over here. So over here I've created this called fixed number of packages, and so this will be equal, so number of packages will be equal to that. So I'm going to be using this to keep checking if whether you have made the right amount of drops, and if not, then it will determine whether it's a fail or a pass. So as long as the number of packages is bigger than 0, meaning that we have not used up all of the boxes, then it will continue. So here I'm gonna play the background sound. Now that is the background sound that you hear when the game starts. Then in here I'm gonna check box package, make sure that it's not equal to null. I created a variable called box package. Now box package is just to kind of manage when there is a delivery active. Okay, I'm calling it delivery. I'm referring to, like, it's just to check that, okay, there is a box currently that needs to be dropped, and once, as long as that box has not been dropped, then we're not gonna continue creating basically more boxes. So this is kind of to set that up. So if it's not equal to null and the position is smaller than -50, then we can continue. So this part is basically managing the plane from initial position to end position. Okay, so in here I'm just checking to see that the box package is not null, right? So it means that it is active, and then I'm checking where the position is. If the position of the plane, if the package is active and the position of the plane is lower than -50, then I'm gonna turn off the thumbs up display. I'm gonna turn off the thumbs down display. These are just the icons that I keep that keep showing up. Every time you make a drop, then there's an icon that shows up. So I'm just basically turning off the display for those, but this is just to make sure that it's always off. Okay, that is kind of like to ensure that it's always off and it's never on it when it's not supposed to. So then I will take the plane. Remember, there was plane pause. This is the initial position where the plane starts. So I always have this clone. So every time the plane has basically went past the screen, when it's no longer visible, then I will set it back to the initial position. And then after that, then I will say box package equals to null. So that means that, okay, we're done with our delivery. So there is no package that is active. So only when it is null, then this function, or sorry, this if statement will pass. Once this is null, then we can start creating a new constraint object or assigning the plane a new box. That's what this logic is doing. So we check if the box package equals to null and if plain group exists. If everything is fine, then we just carry on with this loop. Now this loop is also to manage the number of boxes. So initially the number of boxes is set to 3, right? This is equal to fixed number of boxes, which is 3. So every time this loop runs, it will then minus 1. So once all the boxes are used up, then it's not going to be working anymore. So this is like the initial stage. Okay, so that's where that's happening. So this is where we create our boxes according to these conditions. And then here, this is where we manage the animation of our plane. So here we check if the plane does exist. If the plane is not undefined, and we check also if the box package is not equal to null. Then if that's the case, then we move the plane and we also animate the propeller. And then here we create another variable. It's called plane position. It's doing the same thing. I'm just copying or cloning the position, and then I'm going to set the P2P, the constraint. Then I'm going to set its position according to the plane so that it is always moving with the plane. Okay, so this is what that is doing. Then once all of that is done, then we render. Okay, next we're gonna make we're gonna fill up our update physics. Now inside of update physics, it's quite a lot. Well, first we're gonna start by running our simulation. So we're gonna say physics worlds dot step simulation. We give it delta time and steps are 10. And then here we have one massive for loop. Well, this you're familiar with, this is where we manage the rigid bodies. Okay, just to kind of keep track of the physics inside or in the physics world. Well, we just then create a for loop and we create a variable obj3, which will be equal to that object inside the rigid body or in that index. Then we create another one which will be equal to the physics body. In that object, we create motion state. And then we check if motion state is not undefined. Then we pass motion state the transform. And then we assign P to the transform's origin and Q to the transform's rotation. And then we pass that to our obj3 object. That's that part you are familiar with. You know how that works. So there's nothing new there. And then here I'm just going to check the name. To see if the name is equal to delivered, and if it is equal to delivered, then I'm gonna assign it delivered box3. I'm gonna assign it to a new 3.box3, and then I'm gonna set then it to this object. What this does, it will manage the collisions that are happening with the boxes. Now here are 3 scenarios. First, the box is supposed to land inside the container where it's intended, right? And then it can also land on the ground. So as I'm testing the game, then also realize that when the box lands on another box, let's say you've dropped 2 boxes or even 1 box, and then I try to drop it and then that box lands on top of another box, there will not be any registration of collisions. So now there would be no end to the game or there is no keeping also of the score. So then the game breaks because now there's a collision that is unaccounted for. So delivered is to say, first of all, capture that object, right? Which is a box that has already been dropped. So it has been delivered. So it will check as we go through this list whether current active box has collided with an old active box. That's what this is checking right here. So it's just going to check if there is an object called delivered. And if there is, it's just going to assign it a box3 and then set the shape of box3 from that object. That's all that is doing. Okay, here then this is the normal flow where we check the name of the box, which is package. So all of them, the current active box is called package. They're all called package. So it will check the name, and if it is, then this is the box3 object that will manage the collisions for this package. So we say package box3 set from object obj3, and then we say drop box. Drop box is the box3 for our container. Then we will set that from the box group. So this is what we do initially. Then after that, then we'll start doing the checks. We'll say, okay, drop box3 contains box. This is checking to see if the container contains our package, if it fell in there. If it did, then this is what we're going to do. We're going to play the thumbs up sound. This is basically the prompt to say well done, and then we're going to increment the number of successful drops. So num of success drops plus equals 1. And then here we're going to update our score. Our score will be plus equal. Oh, actually, sorry. Let me remove this. I realized that I just did it twice. I'm doing it over here, but yeah, it was also over here. And that was actually the wrong version of it. Anyway, so once we've updated the number of drop, then we're gonna say thumbs up dot style dot display equals to block. So now we're gonna display the thumbs up icon to show that you've made a successful drop. And then afterwards, then we're gonna say obj3.name equals to delivered. So it means that it's done. It's over and done with. Done and dusted. And then we're gonna update our score, which will be equal to the number of successful drops over the fixed number of packages. So that's just the score that you're seeing on the screen. And then over here, we're going to check if the number of box packages is small or equal to 0. So every time we go through this, once a box is delivered, depending on whether it landed inside the container or on the ground, we will always check to see, is this the last box or are there more boxes? And if this is the last box, then after that box has been dropped, it means that we're done. So this is what that is checking, and once it is, then we're going to say game state.gameplay on equals to false. So we're going to be doing this with all of these checks. So in here we check, this is the check for the container, and this will be the check for the ground. So in here, same thing. If it lands on the ground, then we're going to do a thumbs down. It means that it was a fail. We're going to play the music, show the icon, say obj3.name equals to delivered, and then once again check the number of boxes. If this is not the last box, this is not gonna run, but if it is, then it's gonna close that. So we do that, and then we also do this for the last option, that if the box is not landing inside the container, nor did it hit the ground, but instead it fell on top of another box, that's what that check is gonna be doing. So we're gonna do that as well. And then the fourth other scenario is if you don't actually click your mouse and you don't actually drop the box. What happens to the box then? So this else statement is the final cons. Like if none of these are true, if none of these occur, then this is probably what has happened. So it will basically get rid of that box. So it will check all these conditions, and if everything is true, then it will get rid of that box. So what we'll do is, once again, we will play the fail music to show that, okay, you have failed the mission. You did not even drop the box. We're going to show the icon, and then after that, then we're going to remove the constraint. We're going to remove the collision object. We're going to remove the collision shape, and we're going to remove the motion state. So we're going to completely get rid of that object, and then we're going to destroy it. So this is what we're doing here. So here I'm just assigning it to RB shape and RBMS and checking, okay, if the shape really does exist, we destroy them all, and then we will name it undelivered. So this has a different category of undelivered, and then we will also splice it from our rigid bodies array, and then we check also if it's the last box. If it is, then we turn the gameplay on to false. If not, we continue with the loop. Okay, and then in here we're going to check if it's equal to false. So if game state is equal to false, game state.play on equals to false, and the number of successful drops is bigger than package average, meaning the successful drops are bigger than 50%, then it means that it's game over, but you have finished successfully. We are then going to run this. So after 2 seconds, then we're just going to run this. We're going to play the background. So we're going to pause the background music, and we're going to play the success music, and then we'll start displaying all these different elements. So the game end text content will be equal to game finished. The game end text content will be different according to the conditions. So then after we've set the content, we will display it, and then we will also display the restart HTML tag. So that is the button that you will press to restart, and this is just going to take 1 second for this to happen, the transition. So this is all just CSS stuff, and then the main window, because it was the whole time it was on 0, so we're going to set it to 0.7, so it's going to be semi-transparent. So it's just going to create an overlay on the main screen. So this is checking to see if you've ended the game successfully, and this is to check if you've ended the game unsuccessfully. Then it will be game over instead of game finished. Now that we're done sorting out update physics, we are going to go into our render function, and just above this if statement, just before we start this, I'm going to call update physics over here, and I'm going to assign it delta time. Okay, so the next thing is now we're gonna add all of these functions to our start function. We're gonna call set physics, and then we're going to call set graphics. Next, we will call our event listener in here. Mouse down, we're going to check for our mouse clicks, then render. Okay, so now let's go to our screen and see how everything looks. All right, well, I had a problem, but it was a silly thing. Please make sure that you import your gltf loader, because I did not do that, which is very irresponsible of me. And one other thing, which was basically the major thing, the gltf loader thing was not a problem so much. Yes, delta time, because the whole time I was missing a box, but it was because I did not do this. Just make sure that you assign delta time to clock.delta and then pass it in there. Then everything should run smoothly. I'm gonna go back to my browser, and then I'm gonna check out how it looks now. Okay, there's my box, even though it's swinging like crazy. Oh, I think it's because while I was problem solving, I also changed the damping, because I thought this is where the problem was. That's why it's swinging like crazy. So I'm gonna take the damping back to 0.1, 0.1. So let's just refresh and see. But yeah, the point was that, okay, as you can see the loading screen, which is quite rapid. And then here is everything. This is your splash screen, and this is your press start button. And here's the score starting at 0. So we'll see when I land one in, then it should update the score. Got our thumbs up. So this one is gonna land on the ground. There we go. Okay, so we managed to get 2 out of 3, which is a win. So this is why it says game finished, and then we've got, well, restart will always be there. But if it was a fail, then it will, okay, what is happening now? Restart is not working. What's the problem? All right, one last thing that we need to do is do that. That's the reason why my restart was not working. I did not add that. I omitted from adding that in the beginning because it didn't make sense as to what this is, because I hadn't gotten through that part of the lesson. So yes, I have to include a restart here. This is where I created the event listener, so that's why that didn't work. Oh, everything should be fine now. And I wanted to also show you something. Let me just kind of go to that just now. Over here, I told you that this is a part that speeds up after you get to a certain point. So I will play this again and just notice just how slow it is. You know, after you make the drop, then you have to wait for the plane to get all the way to the end, and then it also kind of takes time to, you know, come through. So this is what this is managing. So as soon as it gets past a certain point where it's clear that you cannot make the drop anymore, then it just speeds up the plane so that it can then do the next round. So I'm going to leave it like this, but I'm going to uncomment it later. See, so now we have to wait for that to finish, and then it also takes forever to pop up. This is what I was telling you about. Okay, that wasn't actually supposed to happen that way, but I think I know why it happened that way. It's because, okay, so now I'm gonna uncomment this and speed it up. As seen, it actually started moving fast Like I'm just gonna just pay attention to how, then it's just gonna do that. That's a trick that I just decided to use to speed this whole thing up. There's something that actually, there's something that happened. I'm gonna try to replicate it because I think something didn't work as it should. When a box landed on another box, there was no registration of. So I'm gonna try to land the box on top of this one. Let me see if I can pull it off. It's not really so easy. I have to time it properly. Okay, not happening. But this time it should work though. With two of them, I should land at least on top of them without any problems. Ah, no, man. Okay, I'm gonna try again. Okay, it worked. I thought that there was an issue. You see? Okay, that works. Because last time something happened and it did not show the thumbs down icon. So I thought that was not working properly. But as you saw, I managed to replicate that even when it lands on top of another box, it will still register. So yeah, you have actually learned quite a lot. I mean, if you have to recap on this, we have obviously, I created all of this. So you did not really take part so much in that, but look at how much we actually managed to create, with just a simple idea, but we've got like a cool game that actually works, that you can share with people and let them try it out. Ammojs has got a lot of potential. There are really great things that I think you can create with it if you just use your imagination and keep things simple. If you have watched till this far, then you should definitely subscribe, hit the like button, and press the bell icon so that you can get notified. I just want to say, I hope that you got through the lesson, that it was not long and tedious, because obviously I had to cover a lot of things, and I hope that you are able to take it all in. But you can watch it again. I think that would probably be the best thing, so that you can try to grasp everything that I did. Take it slow, of course, because I try to keep the lessons short so that they're not too long and boring. Anyway, this is it from me. So till the next one, love and peace. I'm out.